Here is the 15th question of the exercise 13.2, and the question is, one card is drawn from the well shuffled deck of 52 cards, and we need to check whether these following given events are independent or not. So first question, he has given that E is one of the event, the drawn card is a spade, and F event is drawn card is an ace. So here we need to check these two events E and F are independent or not. As you know that two events E and F are said to be independent events if probability of E intersection F should be equals to probability of E into probability of F. If these two quantities are equal, then we say that the given events E and F are the independent. So firstly, I am going to check whether these first two events E and F are independent or not. See here, E is the event. The drawn card is a spade. As you know that out of 52 cards, totally 13 spade cards are exist. Therefore, the probability of getting this event E is equals to 13 divided by 52, which is equals to 1 by 4. And event F is drawn card is an ace. Out of 52, there exist totally 4 ace cards. Therefore, probability of the event F is equals to 4 divided by 52. So, which is equals to 1 divided by 13. And we need probability of E intersection F. So, for that, we need the event E intersection F. E intersection F. So, see here, E is the event, drawn card is a spade, and F is the event, drawn card is an ace. So, the cards exist in the event E as well as F is nothing but the ace card with spade or ace of spade. Out of these 4 ace cards, these all 4 ace cards must be involved with the different suits. So one ace card involved with the diamond, and other card involved with the spade, and third card involved with this club, and last card involved with the heart. So totally there exist 13 ace cards, and in that 13 ace cards, one must be a ace, and this ace of spade must belongs to the event E intersection F. Therefore, E intersection F is the event consisting the card ace of spade, ace of spade. Therefore, probability of E intersection F is equals to, there exists only one ace of spade card, therefore 1 divided by 52 is the answer. Now consider probability of E into probability of F. Now what? Probability of E into probability of F, which is equals to probability of E is 1 by 4 into probability of F is 1 by 30, and which is equals to 1 divided by 52, and this is equals to what? Probability of E intersection F. Probability of E intersection F. Since probability of E intersection F is equals to probability of E into probability of F, it means the first two given events E and F are the independent events. So which implies E and F are independent events, are independent events. I hope all of you understood this. Now the second question, observe here. In the second question, E is the event. E is the event. The drawn card is black, and F is the event. The drawn card is king. So now second question. See here. Here also we need to check whether these two given events E and F are independent or not. So first thing, we need probability of E event. So E is the event, drawn card is black. As you know that out of 52 cards, there is 26 black card and 26 red cards. Therefore, probability of getting black card is equals to 26 divided by 52, which is equals to 1 by 2, and probability of the event F is equals to, so F is the event, drawn card is king. Out of 52 cards, there exist totally 4 king cards. Therefore, probability of getting king card is 4 divided by 52, which is equals to 1 divided by 13. And then we need probability of E intersection F. Now what? we need first E intersection F event. So E intersection F event consisting the cards black as well as king cards. So out of 4 king cards, there exist 2 black cards and 2 red cards. Out of 4 king cards, 2 king cards in black colors and 2 king cards in red colors. Therefore, the common cards in E and F is the 2 black cards. So E is the event drawn card is black, F is the event drawn card is king. Therefore, the king with black cards exist in the common, that is E intersection F. So therefore, E intersection F consists the cards black of king cards or king of black cards. King of black cards. So therefore, probability of the E intersection F is equals to probability of E intersection F is equals to probability of E intersection F is equals to only 2 king of black cards. Therefore, 2 divided by 52 is the probability of getting king of black cards, and which is equals to 1 divided by 26. Now check whether probability of E into probability of F is equals to 1 by 26 or not. Now what? Consider probability of E into probability of F, which is equals to probability of E is 1 by 2 into probability of F is 1 by 13, and which is equals to 1 divided by 26. Therefore, this is equals to probability of E intersection F. It means the second given 2 events E and F are also independent events. Are also independent events. I hope all of you understood this. Now the third question. So in the third question, here he has given that 2 events E and F, and we need to check whether these 2 given events E and F are independent or not. So in this third question, he has given that E is the event, the drawn card is king or queen. Total number of king cards in a pack is 4, and total number of queen cards in a pack is also 4. Therefore, probability of the event E is equals to 4 plus 4, 8 divided by 52, which is equals to 4 2 is 4 13. So 2 by 13 is the probability of getting a king or queen card. And F is the event, the drawn card is queen or jack. So again same thing, there exist totally 4 jack cards in a pack. So therefore, probability of the event F is equals to 4 queen cards plus 4 jack cards is equals to 8 divided by 52, which is equals to 2 divided by 13. So probability of getting a queen or jack cards is equals to 2 by 13. And now we need probability of E intersection F. So E intersection F is an event consisting the common cards in E and F events. See, observe here, E is the event getting a card is either king or queen. F is the event getting card is either queen or jack. So in between these two, the common cards are queen cards. And we know that totally 4 queen cards in a pack. Therefore, probability of getting that queen card. So first thing, the cards in E intersection F is queen cards. Queen cards, and therefore probability of getting the queen cards, probability of getting the queen cards is equals to 4 divided by 52, which is equals to 4 ones are 4 13s. Now for identifying whether these 2 events are independent or not, let us consider probability of E into probability of F. So probability of E is 2 by 13 into probability of F is also 2 by 13, which is equals to 4 divided by 169. So 4 by 169 is not equal to probability of E intersection F. So it means probability of E intersection F is not equal to probability of E into probability of F, which implies the third given 2 events E and F are not independent events, are not independent events. I hope all of you understood this question. Now let's start the next question. And the next question is, in a hostel, in a hostel, 60% of the students read Hindi newspaper, 40% read English newspaper, and 20% read both Hindi and English newspapers. Here, let H be the event. Students who reads Hindi newspapers, student who reads Hindi newspapers, and and E be the event. Students who reads English newspapers, students who reads English newspapers. So see here in this question he has given that there is one hostel. So in that hostel 60% of the students read Hindi newspapers and 40% read English newspapers and 20% read both Hindi and English newspapers. So by this given data we may write the probability of the event H. The probability of the students who reads Hindi newspapers is 60 divided by 100, 60 by 100 which is equals to 6 by 10. And probability of the event E, nothing but probability of the students who reads English newspapers, which is equals to 40 by 100, 40 divided by 100 which is equals to 4 by 10. And also he has given that 20% of the students reads both Hindi and English newspapers, both Hindi and English. It means and in the sense intersection. Therefore, probability of students who reads Hindi newspapers intersection students who reads English newspapers is equals to 20 divided by 100 which is equals to 2 by 10. I hope all of you understood. And by this given data, we need to identify. See here, from this hostel, he has to select one of the student at random. From the hostel, he is going to select one of the student at random, and we need to calculate, find the probability that she reads neither Hindi nor English newspapers. See here, in the first question, we need to identify probability of the student who reads neither Hindi nor nor English newspapers, nor English newspapers. So as you know that neither Hindi nor English in the sense not Hindi, not English papers. The students who doesn't reads Hindi and English papers. So therefore it can be mathematically represented as H dash intersection E dash. So which is equals to by the De Morgan's law probability of H union E whole dash. And we know that probability of H union E whole dash is equals to 1 minus probability of H union E, and which is equals to 1 minus probability of H plus probability of E minus probability of H intersection E. So just substitute the given data here. So here he has given that 1 minus probability of H is 6 by 10 plus probability of E is 4 by 10 minus probability of H intersection E is 2 by 10, which is equals to 1 minus 6 plus 4 10, 10 minus 2 is 8, so 8 by 10 which is equals to 10 minus 8 divided by 10 which is equals to 2 divided by 10 and which is equals to 1 by 5 is the probability of the students who reads neither Hindi nor English newspapers. And the second question we need to identify here, if she reads Hindi newspaper, find the probability that she reads English newspaper. See here in this question, there is one of the given event and one of the finding event. Here the given event is she reads Hindi newspaper, and we need to find probability of that she reads English newspaper. So if one given and one finding event is exist, it should be calculated by using the conditional probability concept. So therefore the formula for conditional probability is probability of the finding event is she reads English newspaper. So we considered E is the students who reads English newspaper. Therefore, probability of E divided by given event. Given event is she reads Hindi newspaper. So probability of E by H, and which is equals to probability of E intersection H divides the probability of H. So which is equals to probability of E intersection H is 2 by 10. Divide by probability of H is 6 by 10. So here we can cancel 10. So which is equals to 2 by 6 and which is equals to 1 by 3 is the probability of the students who reads English newspaper when she reads Hindi newspapers. And now the third question here we need to identify. This third question is also based on the conditional probability. So in this question he has given that she reads English newspaper. Find the probability of that she reads Hindi newspaper. So probability of finding event is Hindi, given event is English. And the formula is probability of E intersection H divides probability of E. Now substitute here the value of probability of E intersection H is 2 by 10 divided by probability of E is 4 by 10. So 10 get cancelled which is equals to 2 by 4 and which is equals to 1 by 2 is the probability that she reads Hindi newspaper when she already reads the English newspaper. I hope all of you understood this question. Now let's start the next question. And the next question is one of the multiple choice question. And in this question, we need to identify probability of obtaining an even prime number on each die when a pair of dice is rolled. So we need to calculate the probability of getting even prime number when a pair of dice is rolled. As you know that 2 is the only even prime number in the real number system. So we need to calculate the probability of getting 2 on first die as well as on the second die. So as you know that when a pair of dice is rolled or 2 dice are rolled, the number of possible outcomes in the sample space is equals to 36. And here we need to calculate the probability of the event, let's say E. So E is an event getting even prime number even prime number on both die, prime number on both die in the sense first die as well as on the second die. And we know that the outcome involves with the even prime number on first as well as second die is only that is 2 2. 2 is the only outcome involved with the even prime number on first die as well as on the second die when a pair of dice is rolled. Therefore, probability of getting this event E is therefore probability of getting this event E is total number of possible outcomes in the event E is 1 divided by total number of outcomes in the sample space is 36. Therefore, 1 by 36 is the probability of getting even prime number on both the die when a pair of dice is rolled. So, option D is the right answer. I hope all of you understood this question. Now, let's start the next question. And the next question is, this is also one of the multiple choice question and which is the last question of the exercise 13.2. And the question is, two events A and B will be independent if. So here we need to identify the condition when we say that two events A and B are the independent events. So here he has given that four options and we need to identify which option is suitable to say that the two events A and B are the independent. As you know that two events A and B are said to be independent. The main definition of the independent events is probability of A intersection B is equals to probability of A into probability of B. And we know that if A and B are the independent events, then A dash and B dash are also independent. It means probability of A dash intersection B dash is equals to probability of A dash into probability of B dash. And we know that probability of A dash intersection B dash can be written as probability of A dash into B dash because by the rule of product and replaced by multiplication, which is equals to probability of A dash can be written as 1 minus probability of A into probability of B dash can be written as 1 minus probability of B. So this is one of the condition to say that the given events A and B are the independent events and that condition is exist in the option B. So option B is the right answer. I hope all of you understood this question.